In this video, we're talking about number word problems, and in this particular problem, we've been asked to find a two-digit number, and this is going to be a whole number, where the sum of the digits in this number is 11, and where the number you get when you reverse the digits is 27 greater than the original number. So in other words, we're dealing with two things here. We're dealing with the actual number and then the sum of the digits. So for example, if our original number was 12, that would be a two-digit whole number. The sum of the digits would be 1 plus 2 is equal to 3. So the sum of the digits would be 3. And when we reverse the number, so when we reverse the tens and the units place and we call the number 21 instead of 12, then the value of the reverse number, 21, is 9 greater than the original number, 12. So we have 12 plus 9 equals 21, right? 21 equals 21. They're asking us for this original number where the sum of the digits isn't 3, it's 11. And when we reverse the digits in the number, when we reverse them and we get 21, this value here, 21, is actually 27 greater than our original number, not 9 greater like in this example. What is this number going to be? How are we going to figure that out? We have to realize that we have a tens place and a units place. 1 is in the tens place and 2 is in the units place. So we'll go ahead and write our original number as TU. We know that the sum of the digits in this number is 11. So we know that T plus U is going to be equal to 11. This equation here deals with the sum of the digits, but when we're talking about the original number, like for example, if we were talking about 12 here, the original number in this first example, how would we get to 12 if we put this in the format TU, tens place, units place? We would say 10 times T plus 1 times U, because the tens place is worth 10 and the units place is worth 1. In this original example here with 12, we have 10 times 1 because 1 is in the tens place, and we have 1 times 2 because 2 is in the units place, and that would give us 12. 10t plus 1 times u is always going to be our original number, but this is saying that when we reverse the digits and we say 10u plus 1t, that this is going to be 27 greater than our original number. So in order to balance this equation, we have to say plus 27 over here, because this is 27 greater than this one, so we're going to have to add 27 to the original number in order to make these balanced. Now when we simplify this equation, we're going to get 10t plus u plus 27 is equal to 10u plus t. If we subtract t from both sides, 1t from both sides, we're going to get 9t plus u plus 27 is equal to 10u. When we subtract 1u from both sides, we'll get 9t plus 27, because this u will go away here, is equal to 9u. Now we can divide through the entire equation by 9. 9t over 9 gives us t, 27 over 9 gives us 3, and 9u divided by 9 just gives us u. If we subtract u from both sides, we have t minus u plus 3 equals 0. And now if we subtract 3 from both sides, we get t minus u is equal to negative 3. What you can see now is that we actually have a system of linear equations. If we bring this up here, we have t minus u equals negative 3. We have two equations defined in terms of two variables, so this is just a systems of equations problem. What we can do is add these two equations together, because when we do that, we'll have a positive u plus a negative u, or just u minus u, which is going to be 0. Those two will cancel and we'll be left with t only. So when we add these together, the result that we're going to get is going to be t plus t, which is 2t. U plus a negative u, or u minus u, is 0. That goes away. And then 11 plus a negative 3, or 11 minus 3, is going to be equal to 8. Dividing both sides by 2, we get t is equal to 4. So now we have a value for t, and we can plug this value for t back into this equation here to find a value for u. So when we plug this in here, t equals 4, so we get 4 plus u equals 11. Subtracting 4 from both sides, we get u is equal to 7. So we have t equals 4 and u equals 7. Remember that we said our original number was TU, with t and u right next to each other. So if we put these together as t and u, we get an original number of 47. So this should be our answer, but let's check to make sure that it fits all the criteria we were given in our original problem. So it says, find a two-digit number, this is a two-digit number, where the sum of the digits is 11. Well, 4 plus 7 is 11, so we're good there. and we're the number you get when you reverse the digits. So when we reverse the digits, we get, instead of 47, we get 74, where 74 is 27 greater than the original number 47. So when we take 74 minus 47, we should get 27. So we get 6 here, 14 minus 7 is 7, 6 minus 4 is 2. We do get 27. So that means that 47 is in fact our final answer.